This movie is going to demonstrate logical constraints. Constraints are part of the Advanced Shape Editor, which is a new routine available in Solid 2011. It's only available to those using Solid Ultimate or Solid Ultimate for closets. Dimension constraints are covered in a separate movie. Constraints in general are a method of applying intelligent parametric rules to parts. When you are shaping and editing objects, if you want to control the part's shape, you will need to utilize constraints. Logical constraints let you maintain logical geometric relationships between lines and arcs. You can apply these relationships between lines and arcs that belong to the same shape. Constraints are fully explained in the help files, so if we go and look, I'm going to just do a search on constraints. I'm going to display the general information about constraints. This describes both dimension and logical constraints. And if you notice, there is also a constraint tutorial which steps you through a few exercises getting you used to this. So let's take a look. To save time, I have already placed some objects on the wall. I'm going to zoom in on this first object and right click and edit shape. You'll notice now we have the list of logical constraints, and there are 10 for you to utilize. The first one I'm going to talk about is the coincidence. Coincidence option allows you to constrain a line or arc's endpoint to another line or arc's endpoint so that it is coincident or similar to the other. To maintain a closed shape when you are editing, the endpoints should always have a coincident constraint. Let me illustrate this for you. If I select the front line here, you'll see that this is a face and the coincident indicators are already on here. Now we do this by default for you, so let me show you how you control that. If you go to the Preferences button, Auto Constraints, Generate Constraints Automatically is chosen and Coincident is there. And as you can see, you have the option to automatically place all the others, but I caution you about doing this unless you're really certain of what you're doing. Otherwise you could get some very unexpected results. To show you the difference in these, I'm going to stretch this front face. I'm just going to pull out the parallel stretching line, and if I save it, you can see that it has been stretched. If I now back to the Constraints button, I'm going to uncheck this. So now let me delete this object and place another one back out there. And if I right click and edit shape, if I click on the front, you'll notice that this time there are no constraints. And to illustrate the difference, if I try to stretch this front face again, you will see that the other endpoints no longer being constrained do not stretch. And to check this, if you tried to save it, the shape is not closed and it would not allow you to do that. So obviously we always recommend that you leave on at least the bare minimum. Continuing on, the next one I'm going to illustrate is the x-axis. For this, I'm going to need to remove the constraints from this line just to illustrate this. I click on that and hit the delete button, and the constraint goes away. Now if I assign the x-axis constraint to this line can never be out of parallel with the x-axis. For example, let me save this, and now I'm going to re-edit, select this. You can see over here on the left the angle is at 0. If I enter, for example, 15 and click enter, you can see that the line does nothing. It will not move off of this x-axis. Now I can enter 180 and go all the way around, but again, if I try to do something like a -150, it's not going to leave the x-axis. And the same thing applies to the y-axis. So I'm not going to demonstrate that. We have already talked about coincidence. Next thing I wanted to talk about is parallel lines. I'm going to set the constraint of parallel lines to this line as my first one, and then I'm going to move over and click this one as the second one, or as its parallel partner. I'm going to save this shape. Now we're going to come back and show you the result of the parallel. If I take this line and, for example, I change its, let's change its angle to minus 80 degrees. Not only does this change, but you can see this line also changes. It has to, because it has a parallel constraint to it. The next one I want to show you is a little unique, and that is the concentric. Concentric option allows you to constrain multiple arcs or circle centers to each other so the center points are shared. If I click on concentric and click this line, I then pull down and click this line. And what this shows us, back up, is that they share the same center point. To prove this, I'm going to go to the arc by radius. I'm going to select the center line for these two arcs, and I'll pull this down and click on the first one. And as you can see, as the circle gets developed, the arc is maintained at this center point. Now I can do this for the second one as well, and again the arc is maintained from that circle so that they share the same arc. If I now try to stretch this one out, you can see already that the arc is maintained and it is shared again. And of course, to prove that, you'll just simply go back and throw up another arc coming off of the center point. This concludes this movie about logical constraints, which we are calling Part 1, and we will continue with the logical constraints in the Part 2 movie.